Let's look at an example on page 415, number 14. Independent random samples of professional football and basketball players gave the following information. So it gives us the weight in pounds of pro football players. There was a sample size of 21. The weights in pounds of professional basketball players, sample size of 19. Part A just asks you to verify the mean standard deviation of each sample. This approximate sign. You don't want to use these numbers in your calculations at all. You just want to, once you get your lists in your calculator, you can double check these to make sure you didn't make any mistakes typing them in. Let's look at part B then, that says let mu1 be the population mean for x1 and mu2 be the population mean for x2. Find a 99% confidence interval for mu1 minus mu2. Okay, so we need to put those in our calculator. I have already typed them in L1 and L2, so you might want to hit pause and just type those in so we can follow along. We do second quit to get out of our data. So the way we do our confidence intervals, we do stat. We go over to tests. We're going to go all the way down. We had previously used Z interval and T interval. But what we haven't used yet is the 2 sample Z interval or 2 sample T interval. We did use the 1 prop Z interval. So in section 7.4, you're going to be using 2 sample Z interval, 2 sample T interval, and 2 proportion Z interval. Again, the difference between the 2 sample Z interval and 2 sample T interval is the same that we did for a Z interval and a T interval. So remember that difference. If we do not know our population standard deviation, or sigma, we have to use a T interval. However, if our sample sizes are both larger than 30, we can go ahead and use a Z interval. If we know our population standard deviation, sigmas, we can go ahead and use the 2 sample Z interval. And then when we know that we're dealing with proportions, we will use the 2 proportion Z interval. There is a page in your textbook that is a nice diagram of showing you how to determine what problem you're using. We read the problem and determine there are 2 samples. One sample we would be using the last section. Once we read the problem, we look, are sigma 1 and sigma 2 known? Then we use, they have the formula here, but that's a Z interval. If sigma 1 and sigma 2 are unknown, we use the T interval. However, if there's reason to believe that these 2 population standard deviations are equal, we can pool our estimate for our standard deviation. I'll show you how we do that on the calculator. So in this problem, it didn't give us any indication that those were equal. And we do not know sigma, so we're going to use the 2 sample T interval. Remember, we don't know sigma. So we go to 2 sample T interval. So we're going to use a 2 sample T interval. Okay. We're going to choose data because we have that typed in L1 and L2. Your frequency just stays 1. It's how many times each data value occurs. Confidence level for this problem was 0.99. This is where the pooled comes in. If for some reason we knew that sigma 1 equaled sigma 2, we could choose yes here. Most of the time, I don't think of any of these problems we do know that, so we always say no. So just say no. And we calculate. Okay, so I have 43.076 and 64.583. Now remember, we're not just estimating mu here. Remember from my prior video when I explained what we're estimating mu1 minus mu2. Okay? We now have to interpret this interval. And my other video shows you if these are both positive numbers, what does that mean? That means that mu1 must be larger than mu2 because they're both positive. These numbers aren't estimating these means, they're estimating the difference. So in this problem, we are 99% confident that the population mean weight of football players, because that was our first sample, is larger than the population mean weight of basketball players. Okay, so the interpretation here, you're not estimating their mean. You're saying which one you think is larger, if there is at all a difference. Okay? So the question is, do professional football players tend to have a higher population mean weight than professional basketball players? And we would say yes, they do.